Continuation of Chapter 1, Section 7, Linear Inequalities. We're going to talk about solving compound inequalities and solving absolute value inequalities, and then finally doing some application problems with inequalities. And you'll have a graded worksheet that goes along with this part of the lesson. So, solving compound inequalities. Notice where x is. X is in between these two inequality symbols, right? So if I cover this up, you see they're in between the two inequality symbols. Folks, you could separate this into two inequalities, meaning you could write 2x plus 1 is greater than negative 3. And then you can cover up this part and say 2x plus 1 is less than or equal to 3. And you can solve them separately that way. Or, I don't necessarily like to bust them apart like that because I just say x is in the middle, so isolate x in the middle. But whatever I do to the middle, I have to do to the left side and to the right side of those two inequality symbols. All right, so example 1. Which actually is example 5. Why? Because we did the first 4 examples in the first part of Chapter 1, Section 7 notes. This is just a continuation of the stuff that's in your book. 1 is less than or equal to 2x plus 3 is less than 11. All right. I said that I look at x is in the middle. And so whatever I do in the middle, I do on the left side and the right side. So I'm going to get rid of this 3 by subtraction, and I'm going to subtract it in the middle, I'm going to subtract it on the right, and I'm going to subtract it on the left. 1 minus 3 is negative 2, less than or equal to 2x, less than 11 minus 3 is 8. X is almost isolated in the middle, not quite. I'm going to divide, right? So I'm going to divide by 2 to get rid of it. If I divide there by 2, I have to divide both these places as well. So I get a negative 1 is less than or equal to 1x, which is less than 4. Solve and graph the solution set. Okay, well, I solved it. I'm going to graph it, and then I'm going to give my answer in interval notation. So negative 1 is to the left of positive 4. I need a bracket on negative 1. If I read it backwards, it's greater than, so I'm shading to the right at negative 1. I need a parenthesis on 4 because I do not have an equal to sign. I'm shading to the left, and the shading is going to come in the middle. My answer in interval notation is bracket negative 1 comma 4 with a parenthesis, and I'm done. Not too bad. Compound inequalities. Now your absolute value inequalities. The dynamics of this is going to change a little bit depending if I am less than or greater than. And remember with absolute values you have to set up 2 cases. One for the positive case, one for the negative case. Meaning the positive case of what would be inside the bars and the negative case of what would be inside the bars. If x is an algebraic expression and c is a positive number, remember this guy's got to be positive number, well, especially with our equations, then the solutions of the absolute value of x being less than c are the numbers that satisfy x is between negative c and positive c. Less than, less than. All right, we don't have any equal to's here because, there's no equal to's. All right, my graph for this would look like parenthesis, negative c, parenthesis, positive c, and shade between. So when it's a less than, it's a shade between. But the solutions of the absolute value of x being greater than c are the numbers that satisfy x is less than negative c or x is greater than c. And that's going to be a split graph, if you remember this from Algebra 2. Negative c shading to the left, positive c shading to the right. That's the split graph. Either solutions are on this piece or on this piece. But there is a disconnect. They are disjoint. They're not connected. Like up here. Now, the mnemonic device that I use to help me remember is, since this is greater than, I remember this and I spell greater as greater. Okay? Greater is the or is the split graph. The less than is the in-between graph. Or come up with a different way to help yourself remember when it should be a split graph and when it should be an in-between graph. Let's do an example. We have another one on the back after this one, but we'll do this one right now. Absolute value of x minus 2 less than 5. It's a less than. I'm expecting shade between. Okay? Less than. Shade between. Now be careful, because sometimes you have to divide by a negative and it flips the sign, and then that would be a greater than, which would be an or. But this one right now, the absolute value expression is already isolated, right? So if I cover up the inequality symbol in this 5, there's nothing in the front of it, there's nothing behind it. So it's already isolated, and that rule still applies, just like we did with the equations. All right, now I'm going to set up my two cases. Case 1, case 2. Now, remember with the equations, we took it out, we set it equal to what was there. We took it out, we set it equal to the opposite of what was there. We're going to do the same thing, except we have to flip this sign. Okay, so the first case is x minus 2, keep it, x minus 2, flip it, switch it. Because remember, it's really like we're dividing both sides by a negative, so you have to flip that sign. Think about this too. If you flip an equal sign, it still looks like an equal sign. Okay, when you flip this sign, it doesn't look the same way. It's not pointing the same way. It's pointing the opposite way. So you take it out, keep it, take it out, flip it, switch it. All right, so let's solve these two baby cases. So I'm going to add 2 to both sides. X is less than 7. I'm going to add 2 to both sides. X is greater than negative 3. Now when I put this together on a graph, I've got, I'm here at 7 and shading left. I'm here at negative 3 and shading right. So, and not equal to, right? So there's a parenthesis there. And just as I expected, I'm shading between. Okay, so I don't think too terribly difficult. But the thing is, you have to make sure this is isolated. And then, you know, kind of figure out if you should be shading between or shading in opposite directions. Okay, the next example. Well, it's still absolute value of 2x, subtract 5, greater than or equal to 3. So, you know, make sure that you remember that this is isolated, okay? You can't do this until your absolute value expression is isolated. And sometimes it won't be. So keep that in the back of your mind, okay? Write that on your notes or something, I don't know, for when you do your homework. Sometimes the examples in the book aren't always representative of what they ask you to do in the problems. Now, nothing's going to change because that's already isolated. Yes, I've got nothing in front of it, nothing behind it till I get to that inequality symbol. So it's isolated, and this thing is not going to change. This is my greater. Okay, so greater means I should have a split graph. All right, I'm ready to set up my two cases, right? I've got 1, 2 absolute value bars. I need 1, 2 cases. So I take out what's in there, 2x, subtract 5, keep the symbol, keep the sign. Take what's in there, 2x minus 5, flip the symbol, switch the sign. solve the two small inequalities. 2x greater than or equal to 8, divide x is greater than or equal to 4. Add the 5, 2x is less than or equal to positive 2, x is less than or equal to 1. When I graph this, here I start at 1, I shade left with a bracket. Here I start at 4, I shade to the right with a bracket. So 1 is here, 4 is here, and your graph is going to look like this. Either the solutions are on the left side or on the right side. None of the values in between 1 and 4 are going to make this true. You know, if you substitute, let's pick a value of 2. If I put a 2 up here, 2 times 2 is 4. 4 minus 5 is negative 1. The absolute value of negative 1 is 1. 1 is not bigger than or equal to 3. If I put a 1 in there, 2 times 1 is 2, minus 5 is negative 3. Absolute value of negative 3 is 3. 3 is not greater than 3, but it is equal to it. Okay, what does my answer look like in interval notation? Well, this is negative, right? Negative infinity is always on the left side. Positive infinity is always on the right side. So I'm going from negative infinity up to and including 1. With a bracket on 1, I'm also including solutions from 4 to positive infinity. And I want both of these at the same time, so we use an in union with. Folks, you must have the U. If on a test or a quiz you don't have the U, I'm going to take points off. Okay, because the solutions are here or here. This means or. Okay, without it, what are you trying to say? Okay, we need to know that both of these are parts of the solution. Okay, so don't forget that. Don't forget to include the U. All right, one more concept to get through on this note sheet. And that is our word problems, our application problems. So just like we did with English to math with the equations, we're now going to do with the inequalities. You have to think of this in terms of what's like going on. X is at least 5. Huh. X is, I always resort it to like, shopping. Whether I'm shopping, at the mall or at a grocery store or at a clothing store or shoe store. It doesn't really matter, some store. Or if I'm selling stuff, whether I'm selling stuff online or I have a yard sale. So if I'm selling something and I want to get at least $5 for it, would I take less than $5? And you're like, well, no. If I want to get at least $5, I'm not taking less than $5. So at least 5 means 5 or more, or X is greater than or equal to 5. Because I will take 5. I'll take more than 5, but I don't want to take anything less than it. So X is at least 5 is an X is greater than or equal to 5. X is at most 5. Now I'm the customer at the yard sale. At most I want to pay for that is $5. Will I pay more? I will not pay more. Would I pay less? Yeah, I'll pay less, but I'm not paying more. So here's my X is less than or equal to 5. See, at most means okay with the 5, just not more than 5. This one here is pretty easy. X is between 5 and 7. So you write the smaller number, the X in the middle, the larger number, and the arrows always point left. Now be careful with this word between. Between means not 5 and not 7. Think of it in terms of geometry, okay? An acute angle measures between 0 and 90 degrees. It can't be 0 or it's not an angle. It can't be 90 or it's a right angle, not an acute angle. So between means not include. Now be careful when you're doing your worksheet with your application problems. If it's not equal to, and it's between two values, you must use this word between. So I'm going to be pretty particular on the vocabulary you use in your sentences. And make sure you're writing sentences. All right, this one. X is no more than 5. No more than 5. Can't be more than 5. Can be less. So here is my x is less than or equal to 5. X is no less than 5. No less than 5. It's got to be 5. It can't be less than 5. It can be more than 5. X is greater than or equal to 5. So again, sometimes you might have to relate it to something else, like shopping or selling, in order to figure out what's really going on and which way your inequality symbol should go. All right, one application problem. A car can be rented from Basic Rental Company for $260 for the week with no extra charge for mileage. Flat fee. Continental charges $80 per week. Well, that's a savings. But they're charging you 25 cents for each mile driven to rent the same car. Under what conditions is the rental cost for Basic Rental a better deal than Continental's? Well, I'm going to write a model that represents the cost for Basic Rental. The cost for Basic Rental is $260. Bam. Continental cost is $80 plus 25 cents for each mile, 0.25 M. Now, if I want Basic Rental to be a better deal than Continental, so I'm doing a comparison between Basic Rental and Continental. If I want this to be a better deal, would it cost more than this or less than that? Well, you should say less than. Should I use the equal to? No, I should not use the equal to, and I'm hoping you said no, because if I use the equal to, then it's the same deal and not a better deal. Now I can take my models for the cost and substitute them into my verbal model right here. So I've got 260 less than 80 plus 0.25 M, M meaning miles. So I'm going to combine this. I'm going to take the 80 over 260 decreased by 80 is 180 less than 0.25 M. Now I like my M on the left side. So I'm going to switch this. I'm going to switch sides. M, 0.25 M. I'm going to move the 180 over here. Now, folks, when you do that, you have to flip the symbol. The inequality arrow is pointing at the 180. When you switch sides, it still has to point at the 180, right? Because if I'm reading this backwards, 0.25 M is greater than 180. So when I switch sides, it's got to be the same thing. Now I'm going to divide. And I see that M is greater than 720, right? So 180 divided by 0.25, 720. So what does this mean in terms of the original problem? Well, you have to write a sentence to describe and give your answer. Under what conditions is the rental cost for Basic Rental a better deal than Continental's? So we would say Basic Rental is a better deal if you drive and here's where sometimes students lose points. They say if you drive 720 miles or more. You can't say if you drive 720 miles or more because the 720 is not included. Okay, so be careful with the verbiage that you choose when you're writing your answers. Basic rental is a better deal if you drive more than 720. More than. You can't say 720 or more because that means including. Okay, so it's more than 720 miles per week. So if you know you're going to use this rental car a lot, then basic rental would be the way to go. But if you're not going to drive that many miles, then Continental is the better way to go. Okay, so again, what do? Set up models for the costs. Set up a model. What's going on? I want basic rental to be a better deal. It would cost less. Substitute into the model. Solve. Note what your inequality is saying. I'm not including 720, so basic rental is a better deal if you drive more than this many miles per week. Okay, if you have any questions, please post a comment on the homework discussion, ask me in class, or pop into a Google Meet. Have a great day.